Hello, fellow citizens of Earth, and welcome to Space News from tomorrow for May 8th, 2019. And let's go ahead and jump right into our launches with space traffic. A little suborbital action to whet our appetites from Blue Origin's New Shepard on NS-11, the 11th test flight of the New Shepard booster and capsule. Launching on May 2nd from Corn Ranch Spaceport in Van Horn, Texas, liftoff occurred at 13:35 Universal Time. Accelerating into a clear sky, 2.5 minutes after liftoff, separation between the booster and capsule allowed 38 microgravity experiments, 9 of them sponsored by NASA, to gather data as the capsule coasted to an apogee of 105.5 kilometers. The booster returned on a ballistic trajectory, deploying air brakes, and slowly lowered itself to a gentle landing not far from the launch site, completing its 5th flight. A capsule came down under its own parachute to soft retro-rocket assisted landing in the Texas desert not far from the launch site as well.
3, 2, 1, 0. Ignition, liftoff. Air Dragon, go Falcon.
A disturbance in the force on May the 4th happened at Space Launch Complex 40 at the Cape Canaveral Air Force Station as the SpaceX Falcon 9 Block 5 lifted off at 06:48 and 58 seconds Universal Time, lofting a cargo dragon to the International Space Station. After separation, Stage 1 performed its now customary turn and burn and successfully landed on drone ship Of Course I Still Love You. Stage 2 continued firing and placed Cargo Dragon on track for a May 6 rendezvous with the International Space Station.
3, 2, 1.
First motion.
We then go to the southern hemisphere for the dark side of the force to make a showing on Revenge of the Fifth, with Rocket Lab's Electron, that's a funny-looking cactus, lifting off at 0600 Universal Time from Rocket Lab Launch Complex 1 on the Mahia Peninsula in New Zealand. A flawless ascent placed 3 technology demonstration satellites for the United States Air Force and the United States Army Space and Missile Defense Command into a 500-kilometer high orbit at 40 degrees of inclination. This was the heaviest payload launched by Rocket Lab so far, weighing in total at roughly 180 kilograms. Finally, on Monday, May 6, the Cargo Dragon for CRS-17 rendezvoused with the International Space Station, carrying roughly 2,500 kilograms of cargo and science equipment. A loose umbilical raised a few questions initially about capture, but controllers in Houston, Texas at NASA's Johnson Space Center cleared Dragon, which eventually was captured at 11:04 Universal Time, with berthing occurring to the nadir port of station's Harmony module at 13:33 Universal Time. Experiments such as Orbital Carbon Observatory 3 and supplies like food and scientific equipment will be unloaded in the weeks to come. That's all we have for our space traffic this week. So let's talk a little bit about why our solar system is so metal.
Planet Earth is pretty metal, whether it's the metal in your wedding bands or the gold in your grills, or heck, even the iron in your blood. Some of the elements that occur in you as well as around you actually have some pretty brutal origins, way more brutal than a Slayer concert. But exactly how brutal, you ask? Some recent findings published in the journal Nature are going to tell us exactly how. Astrophysicists at Columbia University and the University of Florida have identified a neutron star collision that may have been the source for up to 0.3% of Earth's heaviest elements, including gold, platinum, and uranium. But wait, it gets personal. According to one of the lead scientists, Imre Bartos, this also translates to having an eyelash worths of these elements, mostly in the form of iodine, residing in each of us. By studying the half-lives of isotopes found in meteorites, yes, the solar system's very own time capsules, scientists were able to roll the clocks back, so to speak, and figure out when these elements might have formed. The number they arrived at was just about 4.6 billion years ago, or about 100 million years before the solar system's formation, at a distance of, get this, about 1,000 light years away, which is basically down the street relative to a galactic scale. Thanks to the universe's nifty recycling process, this particular merger would have sprinkled our solar system's primordial dusty gas cloud with just about 0.3% of the heavy elements we find on our planet today. This would have been an event so energetic that, if happened today, would easily outshine the night sky. And for good reason. Heavy elements such as these can only form during the intense energies generated during the collisions of these super dense stellar remnants, or star corpses as I like to call them. This is exciting for a couple reasons. First off, neutron-star collisions weren't even confirmed until LIGO detected gravity waves originating from one in 2017. And now we're able to devise models that connect the atoms of heavier elements on Earth to origins beyond what we used to think was even possible. And of course, the more we know about where the atoms around us as well as inside of us originated, the better overall picture of humanity we can make, as well as understanding our place in space. Talk about a cosmic connection.
So let's take some of that metal and let's build some satellites. SpaceX's Starlink satellite internet program, something critical to the financial future of the company, has had a few more details go public. The FCC has approved a proposal from SpaceX to launch 1,584 of its Starlink high-speed internet satellites into an orbit at an altitude of 550 kilometers, which is lower than the originally planned orbital altitude of 1,150 kilometers. The lower orbital altitudes will help with concerns over satellites potentially becoming space debris. These lower orbits mean that if a Starlink satellite fails, atmospheric drag will bring the satellite back into a destructive atmospheric entry within 5 years. SpaceX also noted that lower altitudes will allow for wider separations of constellations, lower latency rates in data transfer, and allow for finer beams of communication, which lowers spectrum requirements. Hall effect thrusters will be used to maintain orbital altitude and station keeping. Overall, the Starlink network will end up requiring 4,409 satellites. To give you some perspective, the total number of operational satellites currently in orbit around the Earth is 1,957. SpaceX has FCC approval for a follow-on network of 7,518 satellites in an even lower 340-kilometer altitude orbit. So for now, you may be watching our show with land-based internet, but at some point in the future, you may do so through a satellite. And to talk a little bit about how space weather can affect those satellites, here's our very own Dr. Tamitha Skov.
Space weather this week has definitely kicked into high gear. As we switch to our front side sun, you can see monster region 2740 rotating into Earth view. It and its sibling region 2741 are boosting the solar flux here on Earth's day side well back into the high 70s. They also are firing off solar flares like crazy. You can see the pop, pop, pop like little paparazzi flashbulbs going off. And they are launching solar storms like mad. And we're getting closer to the Earth strike zone, so I'll go over that in more detail in just a minute. As we switch to our backside sun, you can see those two regions. They're very magnetically connected, and that's keeping them very unstable and causing them to launch storm after storm, flare after flare. And you can see they span almost half of the sun's length here. So we're definitely going to be dealing with these regions easily over the next week, and easily more than that probably over the next 2 weeks. And we're most likely going to get an Earth-directed solar storm. And as we take a closer look at the activity, back on the 6th, you can see we had almost an M-class flare being launched from region 2740. And as we turn around and we look at the difference images, you can see the strength and power of that region and that eruption by that huge wave that goes whoosh right over the surface of the sun like that. So these storms and these flares are pretty strong. Now on the 7th, just 1 day later, we have yet another eruption. And if you take a look at the difference images here, you can see that hot loop leaving and all that dark stuff being evacuated. This is a solar storm that's been launched just to the east of Earth, probably going northeast. It might graze us, but probably not. But easily, as we continue to have these solar storms being launched almost once a day, the very good chance that we're going to get hit with an Earth-directed solar storm within the next week. For more details on this week's space weather, including how these regions are affecting emergency radio communications, GPS reception, and when and where you could possibly see aurora this week, come visit my channel or check me out at spaceweatherwoman.com.
Thanks for watching Space News this week. And coming up on this week's Tomorrow Space episode this Saturday, we have Cody James of OpenX Education teaching us about a new way to learn. So tune in at 1800 Universal Time. And if you've got any questions, leave them as a comment below. We'll round up the good ones and we'll throw them on the air. And of course, we'd like to thank the patrons of tomorrow. Without your help, we would not be able to do Space News. We would not be able to do our Saturday live show. We wouldn't be able to do any of this. So if you got something out of this show today or the live shows that we have on Saturdays, and you maybe want to consider giving something back to us, you can head on over to patreon.com/TMRO or subscribestar.com/TMRO and do so financially. But if you'd like to give back, but maybe not financially, head on over to community.tmro.tv and you can find a multitude of ways to help us out. So, until next week's Space News, keep exploring.
Action. This is exciting for a couple reasons.
Not even one word!
Got it.